Welcome to Mundito Explains. Have you ever looked at a random object, like your phone, a cup of coffee, or even your own hand, and wondered, why does it actually weigh something? It seems like a silly question. Things have weight because they're made of matter, right? But if you zoom all the way in, past the cells, past the atoms, down to the absolute tiniest, most fundamental building blocks of existence, those little particles shouldn't technically have any weight at all. If they didn't, they'd just zip across the universe at the speed of light. No atoms would form, stars wouldn't ignite, you and I wouldn't exist. So, how do we solve a mystery that deep? Simple. We build a multi-billion-dollar machine deep underground, and we smash invisible particles into each other at near light speed. Back in the 1960s, scientists hypothesized that space isn't actually empty. Imagine the entire universe is filled with an invisible cosmic syrup. We call this the Higgs field. When particles try to move through this space syrup, it resists them. That drag, that exact resistance, is what we experience as mass. To prove this syrup exists, we have to poke it hard enough to kick out a single drop. That drop is a particle called the Higgs boson. The catch? It's wildly unstable and blinks out of existence almost instantly. Since we can't exactly put a quantum particle under a high school microscope, we have to use raw, chaotic energy to find it. Think of it like blowing up a building just to sort through the rubble and see what the foundation bricks were made of. This is Einstein's famous E equals mc squared in action. Energy and matter are two sides of the same coin. When you smash two protons together fast enough, the pure kinetic energy of that crash literally transforms into brand new, incredibly rare matter. To do this, humanity built the largest machine ever constructed, the Large Hadron Collider. It's a massive, 27-kilometer circular ring buried 100 meters beneath the border of France and Switzerland. To walk the whole thing would take you an entire day. Inside this giant ring, protons travel at 99.99999% the speed of light. They go so fast, they loop the entire 27-kilometer track over 11,200 times in a single second. When these beams collide, they generate temperatures over 300,000 times hotter than the center of the sun, recreating the exact conditions of the universe fractions of a second after the Big Bang. To steer these ultra-fast protons, the ring is lined with heavy-duty magnets. To make them work efficiently, with zero electrical resistance, they are cooled with liquid helium to nearly absolute zero, making the inside of the collider colder than deep space. Right now, the collider is undergoing a massive shutdown and phase upgrade. Scientists are ripping out over a kilometer of equipment to prepare for the future. They are replacing the old magnets with ones made from an advanced superconducting compound called niobium tin, or Nb3SN. This pushes the magnetic strength from 8.6 Tesla up to a massive 12 Tesla, allowing scientists to squeeze the proton beams even tighter. By 2030, this high-luminosity upgrade will be ready. Think of it like switching from a dim little flashlight to a massive stadium spotlight. Instead of generating 3 million Higgs bosons a year, it will pump out 15 million, creating an ocean of data for supercomputers to sift through. We aren't just looking for what we already know. We're hunting for clues to explain dark matter, antimatter, and entirely new laws of physics. But let's be real for a second. Why should you care about invisible space syrup or 12 Tesla magnets? Because when humans push technology to its absolute physical limits, the tools we are forced to invent trickle down into everyday life. We call these technological spin-offs. The internet. Because scientists at CERN needed a way to instantly share massive amounts of data across the globe, they literally invented the World Wide Web. You are watching this video right now because of particle physics. Medicine. The precise accelerator tech used for these particle beams directly led to hadron therapy, a highly advanced tool used to target and destroy cancer tumors. Medical imaging. Those powerful superconducting magnets? That is the foundational technology inside the MRI and PET scanners at your local hospital. We didn't spend decades building a giant underground ring just to answer abstract questions about the stars. In trying to understand the deepest, most invisible secrets of the cosmos, we built the very tools that save human lives on Earth every single day. So, the next time you hold something heavy, remember, you're feeling the universe swim through an invisible syrup, trapped by a giant machine underground. What do you think? Is smashing particles worth the billions we invest? Drop your thoughts in the comments below. I'm always listening. Hit that subscribe button, grab a seat, and let's keep diving into the mysteries together. Keep wondering, keep learning, and I'll catch you next time.